Welcome back, everyone. So far, we learned that sine has Maclaurin representation this way, and we're going to expand the terms. And we can take the derivative of sine, and we can define cosine by taking the derivative term by term. The derivative of sine is cosine, the derivative of x is 1, the derivative of x cubed divided by 3 factorial can be simplified as x squared divided by 2 factorial, and so on. So this is a Maclaurin representation for cosine function. Now the question says, hey, suppose you have 1 minus cosine x divided by x squared. What is the power series representation here? All right, how can I use these to rewrite the power series for this function? What I'm going to do, I'm going to just do basic algebra. You have x squared on the denominator, so you can write it as x to the power negative 2. Open parenthesis, 1 minus cosine x. Well, cosine x, well, these are the terms for cosine x. And this is the power series representation for cosine x. So use it. You have 1 minus, open parenthesis, cosine is 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial plus the rest of the term, right? Close of parenthesis. Again, we're just doing algebra, basic algebra. Distribute this negative sign into parentheses and then simplify as much as you can. X to the power negative 2. You have 1 minus 1 plus x squared divided by 2 factorial minus x to the 4th divided by 4 factorial plus x to the 6th divided by 6 factorial. You can continue this process. And here you have, for example, negative x to the 8 divided by 8 factorial plus the rest of the terms. I'm just writing the rest of the terms here. You can continue this process. You can add the rest of the terms as well, as many as you need. So here, 1 minus 1, basically 0. You have x to the power negative 2, open parenthesis, x squared divided by 2 factorial minus x to the 4 over 4 factorial plus x to the 6 divided by 6 factorial minus x to the 8 divided by 8 factorial plus the rest of the terms. Basic algebra, nothing calculus here. Distribute this guy into parentheses and simplify as much as you can. So distribute x to the power negative 2. This guy becomes x to the power negative 2 times x to the power 2 divided by 2 factorial minus x to the power negative 2 times x to the power 4 divided by 4 factorial plus the rest of the terms. X to the power negative 2 times x to the power 6, 6 factorial minus x to the power negative 2 times x to the power 8 divided by 8 factorial plus the rest of the terms. Simplify. So they have the same basis with opposite exponents. This guy becomes x to the power 0 divided by 2 factorial minus x to the power 2 divided by 4 factorial plus x to the power 4 divided by 6 factorial minus x to the power 6 divided by 8 factorial and so on. So now we're going to take these terms and write them in the format of a power series. So you can say that, hey, it starts from n equal to, you can start by 1 or you can start by 0, whichever you feel comfortable working with. You have negative to some exponents, so definitely negative to some exponents. You have x to some powers, so x to some powers divided by something factorial. So if you start by taking n equal to 0 goes to infinity, your very first term is positive, right? So this guy should be negative 1 to power n. If I plug in 0, I get negative 1 to power 0, which is positive. If I plug in 1, I get negative 1 to power 1, which is negative 1. The second term is correct. If n is equal to 2, I get positive term, and so on. What about the exponents? X to power 2n. So far, so good. If n is equal to 0, you get x to power 0. If n is equal to 1, you get x to power 2, and so on. But what about the denominator? The denominator is 2 factorial, right? So it should be 2n plus 2 factorial. When n is equal to 0, you get 2 factorial. When n is equal to 1, you get 4 factorial. When n is equal to 2, you get 2 times 2, 4 plus 2, 6 factorial, and so on. So this guy is power series representation for this function, 1 minus cosine x divided by x squared. This is power series representation. And as you see, we just did algebra, nothing calculus here.